Hey, what's up? Jason here. Today we're going to talk about how to code big systems for a bigger game. I'm going to use MMOs as an example because they're really complex and the systems that go into them are pretty big as well. And I've created a bunch of MMO systems in the past, and really I struggled through the first half dozen or so of them, failed quite a few times, and had to get a lot of help in that learning process. But over the years, I think I've picked up quite a bit and it's become pretty easy. And now I've got a solid step by step process that I follow whenever I need to add a new system to a game that's not something small and trivial. And that's what I'm going to share with you today. So let's get started. The first step to building a big system in a game is information gathering. You really need to know what the system should be, what it should look like, and how it should act before you start coding it and putting it together. So, the first thing I like to do and recommend everybody do is grab a notebook. If you don't have some of these, they tend to go on sale right after school starts. I just buy stacks of them when they're really cheap and use them throughout the year. I definitely recommend you go find at least one, maybe a couple of them, and just have them ready while you're doing this. Now, once you've got your notebook, we come to the real first step, which is to talk to game designers. Talk to whoever's designing the actual system. Some places that may not be a solo game designer who's just building the system on their own. Could be a group of game designers, or it could be a programmer or producer. But usually it's some designer that's taking the lead on this system. And you'll want to talk to them in depth on the phone or on a Skype call or something else. You want to be screen sharing and just going back and forth, understanding what they want to have, what they want to see, and of course, writing down the notes and write detailed notes. Don't just, sketch a word here or there. Write down everything that they're saying that makes sense and is important. Now, when you're doing this, it's not just a process of writing down what they say. This should be a two-way conversation. You should be looking at things that they're saying that maybe could be expanded or simplified to make it better use of the game systems that already exist. Like, for instance, if they're designing a system that gives out items, maybe it's one of the recent ones I did was a crafting system. You could give out items, and maybe we've got loot tables or item sets. Instead of setting up an item, should it use that? Maybe it gives stats, right? Like if my new system needs to give stats to a player, again, thinking in an MMO context, it may not make sense to go through the process of complicating up the stat system more and having a bunch of things interact with stats when I could just have this system maybe add a buff to a player that handles the stats that need to be done. Because sometimes it'll just be like this big system that does one little thing that semi-interacts with another system, and I don't want to overcomplicate those things. I just want to take advantage of the other systems and see where I can maybe plug those in. But you don't want to just do that willy-nilly. You want to talk to the designers and make sure that it makes sense to them as well, and that they're not thinking a little bit more advanced down the line, and you're not going to code the system up one way and then find out, oh, that was just kind of the partial idea. The real idea is it's going to be much, much bigger, and it really needs to impact stats or have its own item system or whatever it is. So just kind of go through, and while you're talking to them, look for these different opportunities. Ask a lot of questions. Definitely ask questions nonstop. If anything is not extremely clear, like, I do this action, what is the thing that happens? Every time. If you don't know what that is, ask and find out. Sometimes it'll be obvious. Sometimes it'll be, okay, that's kind of what I assumed. Other times it'll be something completely crazy that you never would have thought of and never would have guessed, so you need to ask these questions. Once you've got that done, though, you need to talk to the programmers on the team. You need to make sure that they haven't already started building a system for this. If they have, you need to find out why it was abandoned, what happened there, maybe what complications that they ran into. Sometimes, developers start working on a system, priorities change, and they bounce over to something else, and they may have some just extra insight, extra knowledge that you need to know that will help you build the system easier and faster. So talk to them and then run by all of the ideas and the other opportunities that you came up with along the way. So if you decided, hey, maybe we should mix in this system with this, talk to them and make sure that they don't have some other idea that why that might be a problem or a better way to do it. You really want to work together. I mean, the whole point of having a team of programmers is to be a team and work together and help each other to make the best thing possible. So make sure that you talk to them in depth. Don't just send them an email and a design doc or a rough draft of a thing. Just talk to them. Tell them what's going on, what you've got in mind. Show them your ideas and your sketches if you got them, and then move on from there. This brings me to the next part of my process, which is sketching out the UI. Now, if your system doesn't have a UI, this might not apply, but most of the time, if we're building a game system, there's something that the player is going to see. And I like to sketch that out on paper in my notebook. Now, I like to do this for a couple reasons. The first is that it helps me build up my data structure ideas. I get an idea of what needs to be there, what the player needs to see, so I know what needs to be sent and maybe what data needs to be saved. But also, it lets me come up with a decent design. It may not be the best design, but I like to sketch out a bunch of different ideas on paper with a pencil or a pen, no eraser, and just go wild with it. So get an idea what that looks like. You can see a couple sketches I did, really bad. And then go to like more wild stuff where I start going with circles and other just random shapes and trying to mix things in and trying different grid layouts. And finally coming to something more like this where I've got a bunch of info and then just iterating from there and keep going. Now, some of the crazy, wild, wacky ideas like the circle that I had might not work as a UI, but you might pull some really good, cool parts from them. And this is a technique that I learned from Billy Hollis at a VS Live event a while back, and I really, really love it because it helps me, like I said, come up with cool ideas for designs, but also just get that data structure down. So I know what I need to send, what the client needs to send, and how that interaction is all going to work. If I try to do this all in code the first time, I'm going to miss things. I'm going to add extra data. I'm going to send stuff I don't need to send or receive things I don't need to receive, and I'll be missing things, of course. So this helps a lot, just giving me the kind of high-level detail view of what I need to have there. But once I have that, I don't just start working on it. Instead, I take that design, those little sketches, and I take a couple of them and I'll show them to the designers. I'll show them to the other programmers. I'll get into a call with them. I'll hold them up to the screen, maybe scan them, show them a picture, just get a rough idea of what I'm thinking, how things would lay out. And again, you don't want to go too detailed on these, but I do put in some little fake data, and I usually, again, put squiggly lines just for text so that I don't have to fill out too much. But you want to get an idea of what it's going to look like filled out with real stuff. So fill out some of the stuff, put in placeholder crap, but don't worry about it being perfect. It's not supposed to be the actual UI or a design doc that you're presenting to people. It's supposed to be you experimenting, sketching, and getting a good idea of what you'd actually like to build. Data structures are one of the important things that I mentioned we get from these UI sketches. Now, there are a couple different data structures that we need to know about and need to use. The ones that really come from the UI sketching, though, are the ones for data that the client is seeing. So in an MMO, for example, we only want to send to the client the data that we really want them to know about. We don't want to send anything that we don't want the player to know. Anything that should be a secret should never get sent because they'll eventually hack it, find out, and know the stuff that we don't want them to know. So we want to find out what those structures are, but we also need the data structures for saving player data. Right? If we've got an MMO, again, for example, or pretty much any game with any type of persistence, we need to save off player data. In a crafting system, this could be like, what recipes does the player know? What have they crafted before, maybe? What special skills do they have for crafting? These may or may not be related to the system. In fact, in the example of the most recent crafting system I did, I just had to save off the recipes. That's pretty much it for the data structure for saving player data. But one other type of data structure that we really need to know about is the content data. Now, this could end up going into a database. It could be coming from somewhere else. I'll talk a bit more about that later. But we need to know what that data looks like. In the case of a crafting system, it could be, what does a recipe look like? Does it have a name? Does it have an ID? Does it have a list of ingredients or a list of things that you get from it? Does it have some skills or whatever the thing is, abilities related to it? Or you just need to know what those things are that are going to be related to your system and put those into the data structures that you're going to use for saving. In my example, I had to have crafting recipes. I had to have items that are ingredients and items that are rewards or results. Pretty much it. Not a whole lot more to the data for a crafting system, at least an initial one. Eventually, you may add more actions and other types of things to make it more complicated, and then you'll have to revisit those data structures. But based on my sketches, I figured out what I needed for the current version, put those data structures together, and then continue on to the next part. The next step still isn't coding. It's coming up with the systems that I need and the controllers and the classes and the structs and the processors. It's all of these high level ideas of the code parts that I need. And I like to just sketch these out as well. Now, I don't write them in detail. I want to be really clear about that. I don't put out like, hey, this class does this. It has all of these methods on it, all of these things, uses these interfaces. I've done that before. It's always wrong. Never guess right on paper. Instead, what I like to do is just kind of block them out. Just a little square showing the key parts of the thing, like, hey, this will have some sort of a controller on this player. It'll have some system, and it'll have some data classes. I want to get those all kind of down and just a rough idea, but I don't treat these as like the end all be all. These can change, and they often do change. It's just a rough idea to get me started and have a kind of an architectural idea of what I want to build. Now, I want to go over the different meanings of these different things. So a system, in the context that I use it, is generally a class that's there for, well, running an entire system. So in the case of crafting, I may have like a general crafting system, but I don't, because it just doesn't really make sense here, because crafting is per player. There's nothing really generic like per world. Now, if I had something that was happening at the world level, like a zone event or a world event type thing, or a world variable, that stuff would go into a system that's just a one-off. And I generally want to have one of each system, I guess, is kind of the point. There would never be a situation where I put together more than one of a system. And again, this is just the wording of the code and the classes. So this would be like a crafting system or a variable system or whatever it is. Now, when I get to the more specific ones to a player, that's where I go to these things that I call controllers. So here I'd have, in this example, a crafting controller on each player. So player gets instantiated, and then it would create its own crafting controller. That crafting controller would have a small amount of data, not much, just enough to know, like, perhaps what the recipes the player has are and whether or not they're currently crafting. Now, that's pretty much the level of data that I want to have in there. I don't want to store a lot. It's mostly just methods that do things. So what would a crafting controller look like? Oh, it would probably have some methods on it like begin crafting, cancel crafting, send recipes to the client, maybe learn recipe and forget recipe. And I think that's probably about it. You may end up with one or two other things on there, but it shouldn't really grow too much beyond that. It just have those specific things. Now, if the crafting system has special actions, it may be like, process action, whatever, and then the crafting controller does that as well, and the state may grow just a little bit there. But in general, it's going to be a relatively simple system that's only responsible, or I said system, but I meant a simple controller that's only responsible for doing that thing on that one object. Now, it's also important to use an interface. Now, you might think, why? Why do I need an interface? It just adds complexity and doesn't really do anything. And sometimes that's the case. If you just add an interface and don't use it, it doesn't add any value, doesn't help. But if you add an interface and use it properly, you get the benefit of being able to unit test. So you can mock these things out. You can replace your crafting controller with a mock controller. I'll talk about that a bit more later. But you also get a nice simple spot to see just how big and exposed this class or interface is. If you have an iCrafting controller class or file, it's not really a class, it's an interface, you'll see in there all of the methods, and you'll know exactly how big that public-facing interface is. And if it starts to look big, you'll know, hey, I've got a problem here. And I find it a little bit easier to find these in interfaces than in classes, because when classes get big, they tend to clutter up, and it's hard to tell what those interfaces look like. When you have an interface that's like this, it works a lot better. But I don't want to blab on about that too much. I want to go on to the next stuff. The last thing in here that I think is really important is the idea of a processor. Now, I've recently been a big fan of these because they feel a lot more functional. And what these are classes that just take a request and some data, they process that data, and then they pass something back out. Very, very simple, and they're very easy to read ideally. If you set it up right, it'll work great. Now, these processors could do anything like finishing the crafting process. It could go through and take the items, remove the items, and add the new items. could apply a buff. It could go through and do any complicated step-by-step process that needs to do some filtering or some just actions on a set of items or set of objects or set of data. That's what I use these for. Now, these tend to be static classes. They're very simple. They have one or maybe two methods in them, and they just do that one thing. So one great example I can think of right now is I have a simple ability processor. If I have an ability that needs to be processed, it comes into this ability processor process method, goes step by step. You can see everything that happens along the way of an ability being activated and used. You can visually tell what's going on. You can step right through it and debug the whole process, and it's very easy to hook into, tie into, and just follow along. Now these work great again because they're really easy to read. Most stuff, most code, very hard to read. You have to bounce all around. With these nice simple static ones that just take data in and data out, it's very, very easy to read. You can tell exactly how it works. Now I want to go on to number 5, which is setting up the databases or the data structures. Your game may not have a database. If it's a big MMO game or a big persistent game, it probably does have some database of some type. It may be a relational database, it may be some NoSQL thing, it may be some custom system that people have built, but it's got some way to store and retrieve data. Now, how you store and retrieve your persistence and content data may vary. So, your NPCs versus your players' levels and players' abilities and stuff could be stored in totally different places and totally different schemas, or even like different ways. You could have that content data in binary files, the other stuff in a database, or vice versa, or whatever you had. Generally, I like to go with databases because they're easy to update, easy to work with, and easy to build tooling around, which I'll talk about in a moment. But you need to figure out where this data is going and how to get that data into the project. Now, if you have a database, you may not have access to go in and start adding these data structures to it. You might need to contact a DBA and have them do it. Give them a rough idea of what things are, and they can set it up for you. But ideally, you want to be able to do this yourself. You want to be able to iterate fast and move quickly, and you want to be able to at least understand that data store, the data structures that are used there, and build them yourself. Now, if you don't have access to a database, you may have a local one that you can use, or you may just kind of struggle with it. But ideally, you want to be able to create these yourself. It's not very hard to learn, but it does take some time. So just work with another developer on your team if you're not sure how this works, and have them run you through the process a couple times. Just go through it with them until you know how to do it, because you'll save yourself a ton of time and make the whole job a lot easier if you can do pretty much the whole thing yourself without having to wait on other people or interrupt people and have any possible blockers. Now, you might also use flat files or scriptable objects or something else. If that's what you're using, just make sure that you understand how it works and that you're able to get data in there. Now, if you can't get data in there, sorry, but you really should be able to. Developing without being able to add data in the development system is extremely limiting and will burn and waste a ton of your time. So hopefully you can do that. And now, when I talk about creating this data, I don't just mean creating the structures. You also want to be able to fill in the data. So once you've got your table of maybe your crafting recipes or whatever the thing is that you're creating this for, you want to be able to fill that up with actual recipes or data that you can use to test and that your designers can use. So you want to be able to create some tooling ideally. Now, not everybody knows how to do this, but if you have a background in Windows or web or anything like that, you may be able to just dive right into building some tools. But your team also should just have some data tooling available so that your designers can go in and put content into your game, right? You don't want to have a game that doesn't have content, and you really want to make getting data into the game as easy as possible. So if you can also, once you've created these new systems, create the tools for them, you'll be saving yourself, again, a ton of time. You'll save a lot of headaches and just get things out a lot quicker. Now, the tooling systems should be built generally so that they're extremely generic and very easy to add to. If your system's not like that, you may want to revisit it and check and see if there's maybe some opportunity to make it very simple. I like to go with systems where I can just define the data model, kind of pop that right into the project and have it automatically generate something that I can start with. Maybe it's dynamically generated based on the model, and then have the ability to go in there and customize and make custom things on top of that. But I want to have, in most of my tools, a way to just drop data structures in there and have it, for the most part, work. I want to be able to get these in 15, 20 minutes and not have a big turnaround where I've got this new data structure and now I need to wait a week before anybody can put data in there and I'm in there manually typing it into the database. Instead, I really prefer and recommend that you learn the tooling process, just get a little bit comfortable with it, get to the point where you can put those in yourself and just make them available. So once we're done with tooling, once we're done with the data, it's time to actually start coding. We're all the way on step 7. So you may notice we go through a whole process here before we start coding. Well, before we start coding game code, because we have coded in here tooling code possibly and a little bit of database stuff. Now this whole process, not that long. We're going steps 1 through 6. This could be in a matter of a day. It could be a week, could be a day. It definitely shouldn't be much longer than that. If it's longer than a week, then you're probably distracted and going really, really slow. If you can get it done very quickly, that's great. It's all just a matter of how quickly you can talk to other people and run it by them. So if you get it all done in a day and you just didn't talk to anybody, then, well, you skipped a bunch of steps and you didn't really get it done in a day. You just kind of cheated and went past everything and didn't do the right things. So I'd say get it done, but get it done quickly, and then you'll be at step 7 where you're actually starting to code. Now, when I say starting to code, I don't mean we're actually putting in the functionality quite yet. Instead, what I like to do next is stub out some of the basic classes and interfaces. So I'll maybe create my crafting controller and the interface for it. And that's it. So it's just the class, the interface, and maybe 1 or 2 of the methods that I think are pretty likely I'm going to use them, like begin crafting. I know I'm going to use a begin crafting. I'll probably use an end crafting, and I'll do something to send them data. I don't know what else, so I'll just put those in there and stub it out. But then I also get the model classes in. I want to get those into the project as quickly as possible so that I have an idea of the data I'm working with and I can iterate on it quickly. Because if I need to change the data model, I may need to change that database and the tooling. So I want to be able to see that quickly and go back and forth. And this is, again, why it's really helpful to have access and ability to modify those tools in the database. Because if you need to make a minor change here, maybe you forgot an integer that you needed, or a data type was just a little bit wrong, should have been a byte, not a int, or should have been an int, not a byte. You want to be able to go in there and change it. You want to be able to do it quickly and not be blocked and waiting. So I like to model these out and then hook them up to the player. So I got like my crafting controller on there. My player now has an iCrafting controller, and I'm ready to move on to step 8. Step 8 might scare people, and that's writing unit tests. Now, this doesn't always happen first, and not every project is going to have unit tests. In fact, I'd say the majority of them probably won't. And if unit tests really scare you and you're thinking, oh, okay, I got to go away, this is too much, I don't want to do that, don't worry, you can still do all of this without unit testing. This is just the step that I really like because it helps a ton in the long term. Now, again, I don't do it every time. I'm not perfect. Nobody is. And probably if I was perfect, I still wouldn't be using unit tests on everything. But I do like to write them. And I like to write them for the new functionality that I'm about to add right before I add it. So if I want to perhaps create a send crafting recipes to the player method, I can write a test around that calls iCrafting controller or crafting controller dot send recipes to player, and then in my test I can check that that test has actually called and sent the network message that needs to go to the player client, and we're good. If it sent, we pass. If it doesn't, we fail. Now, when I write the test at first, it fails because I haven't written the code. I've just stubbed it out. So my crafting controller has a thing that does nothing. It's got that method, the send to player. It does absolutely nothing. Maybe even just throws an exception as like the default. You generate code. It says throw a new not implemented exception. It might even do that. So I'll write the test. The test should fail, and then I will make the test pass. And this is test-driven development or test-driven design, or even behavior-driven design, which is something I'd like to talk more about later, but it's very, very similar and very close. But I like to write these tests and then, just get them working step by step. So I'll build each system piece by piece with the tests first. So get that one little chunk done, then make the next chunk, the begin crafting. Let's write a test for begin crafting. Then I'll hook up the code for begin crafting. I'll make sure that the test passes, and I'll test it manually. So this very important thing, when you do this unit testing in Unity, it's important to not think that, oh, okay, just because the unit test passed, everything is good. There's a lot to the engine, a lot to the game, and you're going to miss something. Your unit tests aren't going to cover everything, unless you're really, really good at them, which I would say I'm not that great. Mine never cover everything. So you want to run these tests manually and just look for other issues, and when you find them, add tests around them. Now, I want to be clear that I don't generally test anything on the UI in Unity. I don't really run any automated or unit testing there because I just find it to be tedious and kind of a pain and not easy. It feels like more work than it's worth, and the UI doesn't change that much. So I don't really worry about that. It's much more on the important functional parts of the server code or the game logic code, the things that you don't want to break so that your player's experience is optimal and that they're not able to easily cheat or just break the game in general. So this is kind of the process. I go through and I do these tests. I write the code and make it all work, and then go on to step 10. So once I've got it somewhat functional, it's working, I think that it's going to be pretty close to what they want, start showing it to designers and start showing it to other programmers pretty quickly. Now, I go to the designers first because they may have some bigger ideas for, oh, this actually isn't going to work this way because I forgot about this idea, or I like that, but I'd like it if you could show this extra little bit of info here, or whatever the thing is. They'll have some really good ideas while you're showing them the stuff and iterating on it. And make sure that you're in step 10 now and you iterate. Don't just build the first thing, send it out, ship it, and then move on to the next thing. Build it, call them up, show it to them. Maybe even before you commit it, show it to them, show them what you've got, how it's going, what it looks like, how the interactions work, and look for those missing opportunities or mistakes or misunderstandings that you might have there. And then you can go in there and fix them, keep going, and just keep iterating. And while you're doing this, just remember that the first thing you show them isn't going to be perfect. It's not going to be exactly what they want. Maybe it is, but it probably won't be. So expect to show them the stuff and get a little bit of feedback, and don't be offended. Definitely don't get offended or upset that what you came up with isn't exactly what they pictured in their mind. That's not something that anybody can do. So you want to just work with them and try to optimize and get the thing perfect. So just keep iterating and keep building on it and do this quickly. So like I said, I like to have really fast turnarounds on these things, get the whole thing kind of up and running as quickly as possible and in the designer's hands as fast as possible. Get them the tooling as quickly as possible so they can start building and showing you where maybe there are some bottlenecks or things that are hard to do or could maybe be simplified, and then go back in and iterate again. Don't ever just build a system and release it and leave it like that. You want to keep building on these things and making them better. You also, final tip here, number 11, that's not on my list, put some content in the game yourself. Don't build them a system where they have to do it and then never actually use the system. Use it yourself, because if you don't, there are going to be issues that you don't know about. There will be things that are a giant pain in the ass, things that are way harder than they need to be, that designers are struggling with every day, that they'll do nice and quietly. They'll never tell you. They'll think, hey, this is the way it's done. I don't want to be a pain in the ass and go complain, so I'll just waste an hour a day doing it this hard way, when they just don't know that, as a programmer, we've got a ton of power and there are a lot of things that we can do to make their jobs a ton easier. So you want to make sure that you just go through that process, look for those things, and fix them right away. If something's a pain to add, make it easier. Once you've done that, watch a designer do it too, because you'll find that they will find hard ways to do things. So always look and see, hey, are they doing something a really hard way? Is there a way to eliminate that hard way, make it simpler, or just make the easy and right path more obvious? Because if there is, you want to do that too. Anyway, I feel like I've talked probably a ton about this, but if you have questions about just building these big systems in general, or you have some other tips or another system that you use, I'm always interested in just watching other people's workflows and learning. So if you've got something like that, please just drop it in a comment below. share it. I'd love to see it and just check it out and learn as much as possible. And I'm sure everybody else watching would as well. Also, don't forget to like, subscribe, and share with your friends. And of course, special thanks to all the Patreon supporters. I really appreciate it. You guys are awesome. Thanks again, everybody.